Okay, good morning everyone to day 2 of the By Design CardinalKit Buildathon. Hopefully everyone got a little bit of rest last night. It was pretty exciting to have all the talks and see all the discussions and the team formation happening on Discord. Today we're going to have a really exciting set of workshops. And I just wanted to go over a few housekeeping items. The Google workshops will be recorded and available. However, the Apple workshops will not be recorded and available. So just be aware of that. Another very important detail is that immediately after the workshop, there's a list. If you go to Discord under announcements, you'll see a list of the office hours that will follow immediately after the talks with the separate Google Meet links. And it'll be kind of an open discussion type session. So that's a really amazing opportunity to have FaceTime with these engineers. So without further ado, I'm going to hand it off to David Marn from Google, who is going to speak on differential privacy. Great to have you, David. Thanks for joining.
Thanks, Oliver. Differential privacy, k-anonymity, anonymization. So all of these are terms that we use and technologies that we use to protect the privacy of the users while still enabling features that make services better for everyone. So for instance, in Google Maps, people want to know how busy particular restaurants are at specific hours of the day. And maybe they want to know what other people are ordering. What are the popular dishes in this place? Now, because the data that's originally used for this is very sensitive, we want to make sure that we're not inadvertently disclosing data that could be used to either re-identify users or allow anyone to infer information about the individuals that contribute to these data sets. So for one, this location information that's used for restaurant busyness is very sensitive by itself. And this is the core issue of anonymization. How do you publish useful information about the population at large without leaking anything personal about the users who contribute to it? But anonymization has lots of other merits as well. It reduces privacy and security risks, and it gives you these statistical insights into the population. And sometimes it's even better because it adds some robustness as well. So it removes some of the collection noise, perhaps outliers, or that were either due to the way that you collected the data or the way that you processed it later. So anonymization is great, but it's very, very hard. There are many, many subtleties and hidden stones that can lead you down these non-obvious ways of inadvertently leaking sensitive information. So maybe let's just go through a hypothetical scenario where we would simply remove the identifiers. So when we publish a data set, we have to go through it, and we remove these personal identifiers like names, first names, last names, birthdays, but we publish the rest. So in the history, this happened very, very often. And the classical example that's also medically themed comes from the state of Washington, where they published de-identified medical records. Now, people quickly found out that you can join this information and decipher it using publicly available records, such as the voting registry, and sometimes even news articles. And we see an example of this on the slides here, where you can now find the name of the person to whom this very sensitive medical document belongs. Now, although this seems like quite a lot of effort to put in, we can also do these things at scale. So for instance, AOL decided to publish their search records that were de-identified. And a little bit more recently, there was this famous Netflix challenge where they published movie rankings for 500,000 customers. And people found out that you can join this with data that exists online to de-identify the movie ratings. So this approach will not work. And the next logical step that we can take this into is to aggregate the data and publish the aggregate statistics. This technique is called k-anonymity, and the k comes from the number of people that have to be present so that we can publish one bucket. So the idea is that as long as K people, and K is usually 50 in academia, so as long as 50 people contribute to some statistic, it's okay to publish it. And these statistics can be averages, counts, sums. Usually you group this data by a certain set of features. So for instance, in the restaurant visit case, we would group it by the location, so the restaurant, and the hour of the day when someone is present. Now, this has quite a lot of problems, although it is a lot better than de-identification. So for instance, if everyone in the dataset belongs to a very biased bucket, you can easily infer information about an individual. So for instance, if you publish a study saying that 50 people participated and all 50 of those smoked, then you have learned something about each individual participating in this study. The second very subtle thing is something called a differencing attack. And this can be illustrated by perhaps me walking into a hospital and asking the hospital about the number of COVID cases that they have treated in this week. And even if they respond with a pretty high number like 314, I can go outside and I can see my friend Peter walk into the hospital, and then I go and visit them again and ask them again. Now, if they say 315 this time, this just leaked some information about Peter. And this, again, seems very impractical in real-life scenarios, but as soon as you're dealing with computer systems, with databases that you can query almost immediately, these differencing attacks can become very, very problematic. And one more example of how much subtleties matter in k-anonymity is when you modify the underlying database. And because these databases are comprised of real-world data, we can imagine a case where the attacker can actually plant some fake entries into the database. And let's say that I'm in the database alone, and the question is maybe, do you smoke or not? If the attacker now publishes, adds 49 entries for people who do not smoke and 49 entries for people who do smoke, then only one of those categories will appear, the one that has 50 entries. And this will then again leak information about me. So the question that's guiding us is there a better way to define anonymity? And the state-of-the-art technique here is called differential privacy. What I love particularly about differential privacy is that it gives us mathematical guarantees. So let's again go through an example. You have a set of users on the left, and you use this data to produce some statistics. So these statistics are nice, but now let's say that we have a similar data set with one person missing. And without loss of generality, we can assume that any one person will be missing. And we again generate some statistics from this new data set. Now, if we look at these results, we should not be able to tell from which data set they came, if they came from the one on the bottom or the one on the top. And if these results are sufficiently similar, then we're not able to say anything about this missing individual in the second data set. So we're protecting the privacy of each individual user while still publishing useful results at the end. Now, intuitively, this makes sense, because if my contribution is not visible in the result, then I will not mind participating in such a study. And again, the reason that we can draw useful information out of these statistics is because we have a sufficiently high number of people participating. Yet we protect each and every single one of them. So let's go to the mathematical definition, where we say that an algorithm is differentially private if the output does not change much when a single person is added to the database. And here we can quantify this much with this parameter epsilon, as well as this parameter delta. And these are now two mathematical variables that we can use to fine-tune the amount of privacy that we will add. So let's maybe go through an example to make this concept of differential privacy a little bit clearer. Let's say that we go to a conference, and then we try to count the number of participants that and ask them about their country of origin. Now we have two different bar plots here, a blue one and the orange one, and the orange one contains an extra person. Now, in this case, it's very easy to see where this extra person is from. They're from France. And again, if we want to protect the anonymity of this person, but also any other person, we need to add some noise. Now, as we add some noise, these charts will start looking different every time that you generate it. And it's a little bit harder to say where this extra person in the orange set comes from. Now, if you look at it long enough, you may start guessing that they come from here just because this bar is often higher than the blue bar. But luckily, because we do have these extra parameters, we can fine-tune the amount of noise to drown out the contributions of any one person to the data set. And even though there is noise in this data, the data is still useful. We can still see some general trends about the population of this conference. So as we scale up the noise, we get a little bit less utility, but a little bit more privacy. And here, the difficult question is now to decide how much noise you need to add. And this relies heavily on the context of the data that's being used. Okay, so now we come to this this difference between the simple conceptual idea behind differential privacy and how difficult it is to implement in practice. So conceptually, we have to add some noise to the data, and this noise has to be carefully calibrated to balance the amount of privacy for each user with the utility so that you can still infer some useful population. And here it's very useful to have large data sets. Then you can imagine that the crowd will then drown out the contributions of any one particular participant, even with noise added. Secondly, it also gives you formal mathematical guarantees. And these guarantees tell us that we can now resist auxiliary knowledge, even if we join these data sets with other data sets. And what's more, we can also compose different differentially private algorithms. And we have theorems that tell us how private the composition of multiple theorems, of multiple aggregations is going to be. Now, as we set out to implement this, we found out that it's, again, a lot more difficult than we imagined. So it's very much like security and cryptography, in that the concepts are easy, but there are many subtleties. When you start implementing things, you have to keep lots of very interesting things in mind, and you discover them as you go on. For instance, modern computers have this way of rounding floating points that looks a little bit like a staircase. So they're not real numbers like the real numbers in mathematics, but because of this staircase-like structure, you can make some probabilistic guesses on the amount of noise that was added. And that allows you to then remove this noise and recover the actual data. Some academic papers also don't have to deal with the complexities of real-world scenarios. So for instance, in the real world, the contributions of any one user are very difficult to quantify. And in papers, they can simply gloss over this and assume that each person will only contribute to a data set once. So knowing this, we've published a paper on differentially private SQL engines, where we also bound user contributions. And this was one of these implementations of differentially private SQL queries that allow you to safely query the data. And here we also describe a lot of technical nuances that we've discovered. I've already mentioned this problem of having multiple contributions. So what happens when an individual visits multiple restaurants, not just one, or if you visit the same restaurant at different times of the day, or maybe at the same times of the day. So we have all these contributions that will ultimately affect the amount of noise that you need to add to hide, to sufficiently hide the contributions of any one user. Furthermore, you have this problem with different categories, where if you have a new restaurant with only a few users, the amount of noise will not mask the fact that you have now added a new category, a new partition. So in this paper, we have also talked about simple ways of replacing known aggregation functions in SQL with their anonymized counterparts. So instead of count, you now have a non-count, and so on. And sometimes we even add new parameters like L and U, and these to refer to lower and upper bounds that you accept, which means that if you have an individual that contributes more, then we will cap those contributions in order to protect their privacy. And here we also see some benefits because we don't want to optimize our services for these outliers that contribute a lot more. And one final thing to mention is that you don't always have to apply these bounds. You can also leave them blank, and the engine can then choose the optimal bounds by itself. Okay, so here's an example of using it. We simply replace count with a non-count, and we can now provide these bounds that will limit the sensitivity of this differentially private query. Okay, so we've also published our code in an open source differentially private library. The idea here is that it's a lot better for everyone if we collaborate and we design these differentially private algorithms together. And by doing this, just like with cryptography and encryption, we can avoid a lot of these pitfalls because anonymization is very hard to get it right. There's already this concept that you don't want to roll your own crypto, but it also applies to privacy and anonymization. The differential privacy libraries that we've published, they started out in C++, but we have also recently added support in Java as well as Go. And the link to this GitHub repository is shared in the Discord chat in the differential privacy channel. So let's switch gears a little bit and talk more about AI and machine learning. In machine learning, you can also use differential privacy to protect the privacy of the users that you train on. So the predictions that your machine learning algorithm will make will not leak anything about the people in the training set. You have a couple of different options here. You can anonymize the data before you begin training using conventional differential privacy libraries, using conventional techniques, or you can anonymize the output. But you also have the option of anonymizing the training procedure. So as you train these neural networks, you can add noise, and this will automatically prevent the machine learning model from learning anything too sensitive. So we at Google have published a package inside of TensorFlow called TensorFlow Privacy that allows you to train machine learning models with differential privacy in mind as part of the training procedure. So in this case, instead of using stochastic gradient descent, we use a differentially private version of stochastic gradient descent. For this to work, you get access to a few new hyperparameters. And as any ML practitioner knows, it's already difficult to balance the hyperparameters so that you get useful performance out of a model by itself. And now that you add these new hyperparameters for privacy, this gets even harder. But after some time, you can tune them for optimal performance. Now, in case that differential privacy is not suitable for the machine learning model that you work on, you can still measure the amount of privacy risks by doing some empirical tests. For instance, we have recently open sourced a library that allows you to execute membership inference attacks. And again, the link to this GitHub page is shared on the Discord channel, but the idea here is that we have this attacker that has a few input examples, and they query the machine learning model that's publicly accessible, and they get some output out of it. And now, as they get the corresponding output probabilities or predictions, they want to decide whether or not these examples were part of the training set or not. And if these examples behave sufficiently differently that it allows you to distinguish between examples in training and examples not in training, this then can be considered a privacy risk. Okay, now let's go and see where differential privacy is used in the wild. What I find great is that this has transcended the boundaries of Google, but also the boundaries of tech. And it's going to be used in the US Census that's done every 10 years. The US Census is extremely tricky because they publish a lot of very granular statistics. I think they go down even to the street block level, and they publish information on the number of households living in the street. And this data is heavily, heavily correlated. So getting differential privacy to work on such an enormous data set is extremely difficult, but it's very great. It's really fantastic to see this used in the open. Then maybe inside of tech, Facebook has published a URL dataset with differential privacy built in to protect their users. Apple is using differential privacy for keyboard statistics on both iOS and macOS. Android is using differentially private machine learning to generate next word predictions on Gboard. And Google has also open sourced the system Rapport that was used for Google Chrome telemetry. And here, the idea is that instead of adding noise in a central place, you add it in the client. So even if the attacker gets access to the raw database from Google Chrome, they will still not be able to say anything about the individuals that contributed to it. Then furthermore, we use differential privacy in a plethora of Google products. So we've mentioned popular dishes, as well as the busyness of restaurants and other businesses. And maybe more recently, we've used differential privacy to anonymize the mobility reports as a result of the COVID pandemic. So we have analyzed the differences in the way that people travel, the differences on the number of visits to different public places, and we've published this on the link seen here. But you can also find more of these implementations on the Wikipedia link below. So thank you for your attention, and I'm happy to answer your questions either here or in the Q&A session that's linked on the Discord chat.
David, thank you. I don't think people know that you're dialing in all the way from Zurich today. Is that right?
Oh yeah, so I'm in Slovenia, but yes, it's a lot later here.
Yeah. Okay. Well, that was really really fantastic. And so I just want to remind everyone that if you go to Discord and announcements, you'll find the link to go to the office hours to have face-to-face.
Good morning, everyone. I'm Andrea Bognari. I'm a product manager here at Cloud AI, and I look after healthcare and life sciences. And together with my team, we're building AI products and solutions for the industry, primarily looking at how we can increase productivity in healthcare.
Fantastic. And if you have slides to share, feel free to share them now, and I'll let you know when we see them.
Absolutely.
And then after this session, we'll be talking about hearing from Google Health about their FHIR API, which is also really exciting. They've done a lot of work and included even imaging. We heard about DICOM imaging, so X-rays and so on. I still don't see your screen. Were you trying to share? Or? Okay.
Yeah, give me one moment.
Sure. While Andrea is working, just to remind everyone that our sessions are going to go through noon today, and after each talk, the speaker will be available on a separate Google Meet to answer any questions, which is always great.
I think I got this.
Oh, yeah, I see it. Great. All right, take it away.
So are we ready to roll? Should I take it?
Yes, sorry. Yeah,
Okay.
Go ahead. Thanks.
So I thought I'd take you guys through a couple of building blocks we developed at Cloud AI to automate how information gets extracted from medical text. So I'm going to talk about the Google Healthcare offerings for natural language. And the goal of these offerings is to increase workforce productivity with AI. Now, the reason why we started doing all of this work is because we did a scan of the industry, and we understood that there's a lot of routine work that gets performed by humans, and that leads to burnout. Also, in America as well as globally, there's an aging population, and this results in a declining labor force participation and a surging need for healthcare services. And in the United States, there's a projected workforce gap that will reach a vacancy of 30% by 2024. So all of these signals, all of these trends mean that there's going to be a demand for more healthcare and less hands available to provide this kind of healthcare. So we developed a solution that can enable both healthcare workers and healthcare institutions to seamlessly share patient information to avoid process delays. This solution will help with identification and elimination of errors that might require corrective activities to be performed by humans. And at its core, the solution will help move low-value activities away from employees by automating mental tasks. And this will enable the employees to go back to working at the top of their license. So I thought today I would take you through an overview of the Healthcare Natural Language API, and then I walk you through a couple of solutions that we can enable in the industry with this technology. So with that being said, we all know that quality healthcare relies on many sources of information, some of which are generated at the bench side, others at the bedside, and most of them more and more in the community. However, 80% of this health data is unstructured, it's in written form, and because of that, it's difficult to analyze at scale. So at the bench side, we're talking about scientific literature. At the bedside, we're talking about medical notes, lab results. In the community, we're talking about information that comes from the Internet of Medical Things devices, or even telemedicine these days. With the Healthcare Natural Language API, we can pick up all of this information and structure it in a format that can be consumed by digital applications. So the Healthcare Natural Language API helps transform unstructured medical data into actionable insights. And this deep learning tool helps a number of stakeholders. It helps pharma companies draw insights for drug development. It helps doctors and care teams get holistic views of their patients more quickly. And it helps health plans see population trends for their members. You can make more informed healthcare decisions with the Healthcare Natural Language API and unlock value at all stages of health data analysis. Specifically, you can streamline and optimize document review workflows. If you're looking at claims processing, there's manual work that has to be done for HEDIS reporting or HCC reporting. You can leverage insights from document data lakes for population data health, or even for risk adjustment for health plans. And you can augment point solutions with language AI. Here I'm referring about solutions like telemedicine or call centers. And at its core, the Healthcare Natural Language API takes you from text to structured insight. If you are to visualize what this building block generates as output as a JSON payload, if that means anything. And in the payload, we structure all of the insight as well as additional characteristics that describe what these insights represent in the bigger ecosystem of medical knowledge. The Healthcare Natural Language API consists of 4 core features that help you find, assess, as well as link the knowledge in your data. There we have a module for knowledge extraction, one for relation extraction. We also have a module for context assessment. And last but not least, the Healthcare Natural Language API consists of a module for knowledge linking. And I'm going to walk through the details of each of these modules. The knowledge extraction module maps text to medical concepts. We target 10 course medical concepts, things like medical conditions, medical procedures, medical devices, body functions. If you pass a piece of medical text or even a PDF through the Healthcare Natural Language API, it will identify every mention of these core medical concepts. And once these medical concepts are identified, the following module, the relation extraction module, identifies and connects related medical attributes. So if we identify a mention of a medication, the relation extraction module will scan the surrounding context to see if there is a mention of the dosage, the duration, the form, and route of administration of that specific medication. It will also scan the surrounding context to see for which specific disease the medication was prescribed for, as well as whether there are any side effects associated with the medication. And these are just some of the medical attributes and relations that get extracted from medical text. The following module, the context assessment module, picks up surrounding factors that could be clinically relevant. There are 3 types of surrounding factors that get extracted: certainty, temporal status, and subject. And let me go through each one and give you a bit of context around them. The certainty function tries to assess the confidence of the author that basically generated the medical knowledge. So when a doctor dictates a medical report, the doctor can say that the patient has diabetes, is likely to have diabetes, might develop diabetes, etc. So the author of this medical report has a degree of certainty, of confidence. And with the context assessment module, we assess and qualify the degree of confidence of the author itself. So keep in mind that this certainty function refers to the certainty of the human that wrote the piece of medical text. It doesn't refer to the certainty of the machine learning model that extracted the information. The certainty of the machine learning model is extracted separately. The temporal status qualifies whether the piece of medical information is occurring in the present, in the past, if it's part of the family history or the clinical history of the patient. And then the subject function qualifies whether the information refers to the patient or the patient family member. And last but not least, once we extract this information with the Healthcare Natural Language API, we enable our customers to standardize the medical insights against industry standard dictionaries. So once you standardize the information, this information can be analyzed across systems. And the reason why standardization is important is because humans are very creative in the way they use language. And they might refer in 10 different ways to the same piece of medical information. Like there might be different ways to say that the patient has diabetes. So we take all of those diverse mentions of medical information and we standardize them against an entry in the medical dictionary like MESH, RxNorm, or ICD-10. So these are the different functions that are performed by the Healthcare Natural Language API. These functions are available off the shelf. However, because the Healthcare Natural Language API consists of deep learning systems, these systems had to be trained, and they had to be trained to a spec. And our customers might have additional needs that were not included in the original spec we designed. And in order to enable our customers to cherry pick additional insights from their data, we've built an AutoML healthcare product that enables customers to build their own models very quickly without having to go into the details, the nuts and bolts of machine learning. So with AutoML Healthcare, you just upload the medical information that you have available within your organization. You highlight the pieces of insights that you want to have extracted automatically, and you click to train a model, and we take care of the model training, the model updates, and the model deployments in production. So the value of AutoML Healthcare is to complement whatever functionality is offered off the shelf by the HealthKit Natural Language API. So together with the HealthKit Natural Language API, you can now have a 360 view of the information that is available in your data. Both products are available as command line tools for people who want a more programmatic, for people who want to take a more programmatic approach. And they're also available as part of the user interface that we've developed at GCP, we call it the Pantheon. So you can go in and access these tools via a web GUI. I wanted to quickly highlight a reference architecture for the HealthKit Natural Language API that articulates how you can combine the pre-trained models, the HealthKit Natural Language API models, with models that are custom developed on your own data, in order to have this like 360 view of the insights in your core data sets. So fundamentally, you start with input data sources that can be sent in to Google Cloud. Once the data reaches Google Cloud, you can set up data proc services, data proc functions that trigger the analysis, the automatic analysis over the input data. And once the data is analyzed, it can be either sent in for review, or it can be sent in for visualization into BI tools like Looker, or even back into an HR system like Epic. With that being said, that's all I wanted to share as an overview of the core technology. And now I wanted to move on and talk about a number of solutions that can be enabled in the industry. Before I do that, I'm just curious whether folks, you've been running a more interactive conversation over here, or I should go through the entire content and maybe take the questions at the end.
Yeah, I would go through the entire content, and then you have an opportunity in a separate Google Meet to have the interactive sessions.
Perfect. So I'll do that then. Okay. In terms of solutions in the industry, as I mentioned at the beginning, the HealthKit Natural Language API can parse information that comes from multiple data sources and can make this information available to multiple stakeholders. And I've articulated in here in this presentation a number of solutions that can be developed for different stakeholders, like the pharma, the provider, the health plan, and the government agency. So let me go through these solutions one by one. When we're talking about drug manufacturers and distributors, their main challenge is identifying new drugs, new medical devices that can help treat diseases, and specifically diseases that are rare. And because these diseases are rare, it's very challenging to identify the patient population that is a good match to test their new solutions. So if you have to think about how clinical trials are run, you design a protocol, inclusion-exclusion with inclusion-exclusion criteria, and you have to run through both numerical data points as well as written medical records to identify who qualifies based on your protocol criteria. And right now, a large portion of this matching work is done manually. This manually doesn't scale, and humans are not are not the experts at covering information holistically. So with an automatic approach, you can review the medical information more comprehensively and faster. So the Healthcare Natural Language API enables you to take the medical records, scan for the pieces of information that are important for the clinical trial, and then decide which patient, which cohort is a good candidate for that specific trial. The challenges in the industry are that patient matching for a study requires manual review of information that sits in medical charts. Participants are often not eligible due to criteria that were overlooked during the manual review. And even when patients are identified and they do qualify for a clinical trial, manually cross-referencing candidates is a slow process. So with the Healthcare Natural Language API, we are able to increase the number of study participants in less time. We can increase the accuracy of the patients that were matched for a specific clinical trial. And at the end of the day, we help impact the bottom line because we decrease the time to FDA approval. So we can help more drugs get to the market in less time. When we look at care providers, we're looking at a tectonic shift across the industry. More and more care providers are thinking about digital health experiences for their patients. And digital health experiences cover a broad range of activities across the healthcare value chain. The disease journey happens with prevention, but if prevention can't stop the disease from occurring, now we're moving into the diagnostic stages, the therapeutic stages, and then the reintegration of the patient into the healthcare journey. And across all of these touch points, there are different service providers that need to interact and communicate with the patient. And right now, this communication happens across different types of applications. It happens across telemedicine, it happens across EHR, patient portals, and it happens across call centers. With the Healthcare Natural Language API, we are able to automatically identify the type of communications that occur across all of these different portals and augment the services provided by the healthcare worker in these applications. The challenges, the fundamental challenges in digital health are that chatbots offer generic interactions, and that creates a poor patient experience. Care is often standardized without looking into the patient's unique circumstances, and manual administration work causes slow processing times, and that leads to, again, a bad patient experience. The solution we're able to enable with the Healthcare Natural Language API is personalized patient experiences in the chat room. We can augment the delivery of care with precise decision support, and we can also help reduce time in billing processes, time spent in the back office. So we're talking about the gift of time because we're helping doctors transition away from the back office towards patient interactions. Now, when we're looking at payers who represent a large percentage of all of the activities that are financed and they're basically taken care of in the healthcare services, payers have complex life cycles and complex value chains. And most of their the value chains in the payer ecosystem are focused around document review. The business process starts with the intake of a document that can be either a claim, or it can be a medical record, or it can be some form of a survey. And this information it has to go through manual review for data extraction. It has to be audited and interpreted before it can be adjudicated and before insights can be generated across the entire population. each one of these steps is highly manual, and each one of these steps consists of large volumes of data that are reviewed daily, monthly, and yearly across different time schedules. The challenges are that handwritten medical notes are difficult to analyze, and it's not just the medical notes that have to be analyzed. Sometimes even claims have to be analyzed and audited. The records are often unstructured and unclassified, so the professional that's responsible for reviewing this information has to also figure out what is the lineage of that data. And because of all this administrative work, we are looking at slow processing times for claims, slow processing times for the payer lifecycle overall. The solution we're enabling with the HealthKit Natural Language API is the automation of document review and automation of insight extraction. We're also able to classify and codify medical records for downstream billing processing. And overall, we can reduce the time spent in the back office. Now, last solution I wanted to walk you folks over, this solution targets public health agencies or the government. The government is a strong proponent of transparency and accountability for the healthcare industry, and they've been participating in the transition of the industry towards this big tenet of transparency and accountability with different types of regulations and different types of guiding rules. The challenge is that every time the government comes out with a new set of regulations or a new set of principles, it takes a lot of overhead for the industry stakeholders to adopt these in practice. And the government fundamentally is asking for information to be sent over for review. It's asking for the industry stakeholders to communicate how they're performing in terms of quality and risk. And this reporting of information sits on a large workforce that reviews data manually in order to submit these insights back to the government for review. So the challenge when we're talking about public health agency is that handwritten medical notes are, again, difficult to analyze, and they have to be analyzed in order for the quality and risk reports to be sent through to the government. And because of this complexity of data review, there are limitations on the type of pub health data that's available for analysis. And not just that, but there are limitations in terms of how much data the government can audit in order to certify that the reports are accurate and representative of the patient population. The solution we're proposing to enable with the HealthKit Natural Language API is automation of this reporting protocols. If we can automate the reporting of information, we can also automate the structuring of insights and the communication of data back into governmental portals. And at its core, all of this information and automation of reporting can lead to a comprehensive analytics of the population health. And with a comprehensive analytics of what's going on across the country in terms of population health, you can design better policies that represent the status quo more accurately. Now, with that being said, those were the different types of applications I wanted to highlight, the applications that we can enable with natural language understanding for medical records. I'm hoping this kind of spiked your interest and you will want to learn more. So I included over here a couple of pointers. The first one is for information to the HealthKit Natural Language API for learning about how to interact programmatically with this technology. And given that right now the technology is in private alpha, you will have to request access to work with it. So there's a link included over here that you can follow to get access to this technology. So that's all for today.
Okay, thank you, Andrea. That was fantastic, and I think your imagination, when you see the possibilities, it's pretty incredible. And for Google to be able to offer this under the BAA which is an important point, the business associate agreement, it's very much a viable solution, an option when you're dealing with healthcare information. So I think that's fantastic. And so there is going to be, if you look at the chat section, we're going to post the Google Meet address for the Q&A to follow if you have time.
Absolutely.
And really appreciate your time today. And so now, if we're going to move to Colleen, who's from the Google Health team and is going to talk, we're going to go back to FHIR and the FHIR API. And I know Google has, done a lot of work to get all the elements, or I believe, you can speak to this more specifically, but I know you're ready to ingest entire EHR data, including DICOM imaging, which is a big deal. And that's incredible. And I'd love, we're super excited to hear where Google is with that and how the API works. And feel free to share your screen and also introduce yourself for us.
Thanks, Oliver. All right, let me pull up my slides first. Can you hear me okay?
Yep, hear you. Yep, right. Your slides are coming up. Looks good.
Perfect. All right. So you can all see my screen?
Yep.
Excellent. So good morning, everyone. My name is Kalyan Pamarthi. I'm one of the product managers on the Cloud Healthcare team. I work closely with Andrea as well. So today I wanted to talk to you all about the Google Cloud HealthKit API. I'll introduce the API, but spend a lot of time talking about our capabilities in FHIR. I am joined by two of my colleagues here, Dharmesh Patel, who's on the Meet here as well. He's one of our managers in the solutions team, works very closely with me with all our developers and customers in making sure that we can help you all work with the HealthKit API, specifically with FHIR. Adrish Sanyasi, who I don't believe is in the call, but will be joining us later. So between myself, Dharmesh, and Adrish, we'll be around for the rest of the day, also to answer questions and help you all develop with the HealthKit API. So just as a quick overview, so the Cloud HealthKit API is part of the Google Cloud Platform and is the primary surface for working with healthcare data, right? And so we've been working on the Cloud HealthKit API for a few years now. I've taken it through various stages of the maturity cycle, so alpha, beta, and earlier this year we launched a general availability. And what we're trying to do with the HealthKit API is help our payers, providers, researchers, software developers who are working with healthcare data be able to securely manage their healthcare data in the cloud. Right, and so all the tooling that we've built and all the API methods that we've built, and I'll share some of those in the next few minutes, are focused on how you can use the Google Cloud Platform specifically for healthcare data, and like I said, securely and privately bring in your healthcare data into the cloud, access it to REST APIs, secure it with the templates and infrastructure that we have. But also export it to other systems. Now, we are huge believers in interoperability, and so we have the Cloud HealthKit API is very focused on advancing the state of interoperability. So we think a lot about all the different data sources that are being used in healthcare IT systems. How do we support the data formats? How do we make it easy for developers to build web applications, mobile applications, AI, ML models, and then also interact with all the other systems that are working in the healthcare ecosystem, right? So whether it's about electronic medical record systems, your radiology systems, or just digital health applications, whether you're collecting patient data, how do you store and access that data in the cloud? So we're also very focused on tooling around compliance and security and privacy. And so one of my peers, Rohit Talreja, will be talking about the infrastructure we have for building HIPAA-aligned systems with the Cloud HealthKit API. So there's a lot of different components of the Cloud HealthKit API. Like I said, think of the Cloud HealthKit API as a container for a variety of different data formats in the cloud, but also value-added services, right? So a great example is what Andrea just presented about the natural language API. We've also got tooling for transforming various types of data into other formats, for example, FHIR. And then we've got tools for de-identifying your data, which is really important in research use cases and analytics use cases. And so we've been building a lot of this over the past couple of years, and are continuing to build on top of the Cloud HealthKit API surface for a lot of different use cases. So I want to spend the rest of the time digging into FHIR API. So we support HL7, FHIR, and DICOM as data standards in the HealthKit API, and we've got a few others coming over the next few months. But we believe that, and we're seeing this in a lot of our conversations with developers, that FHIR is slowly becoming the standard for healthcare app development, right? And we see a lot of the more mature healthcare systems trying to migrate their existing data into FHIR, because FHIR, as you all know, is both a data model, but also a standard for accessing healthcare data. We're also seeing a lot of, I'd say, cloud-first companies, and we see a lot of this in digital health, diabetes management or others, that are building their apps on FHIR, on their FHIR as the primary data model, right? And so we are investing quite a bit in supporting FHIR. We're very active in the FHIR community and tracking the standards to keep building new functionality. So developers like all of you can use our APIs to build FHIR-based apps. I just talked about this. So we support FHIR both as a data model, but also an API specification. So we support all the three widely used versions of FHIR, R4, STU3, and DSTU2. We provide a completely serverless managed services environment. So this is, once you click and set up the HealthKit API, all of your data is securely managed in the cloud. You do not have to worry about, getting Docker images, running them, or setting up your own virtual machines, running and managing your infrastructure. This is a completely serverless environment. We have a lot of tooling around HIPAA. I talked about that. Rohit will talk about it more shortly. We're also very well integrated with all the other technologies that you have in Google Cloud for various other use cases. For example, if you're using Google Cloud Storage as your object storage, the HealthKit APIs are integrated with Google Cloud Storage to enable data import and export. Similarly, BigQuery is a very popularly used tool for large-scale data analytics, data warehousing, running machine learning models. So the HealthKit API and the FHIR data is very well integrated into BigQuery. So not only can you build applications with the FHIR APIs, but you can also export your data into BigQuery for analytics. So let's dig into some of the details, right? And so the concept that is core to the FHIR APIs in the Cloud HealthKit API is this idea of a FHIR store. And you'll hear me talk about a FHIR store quite a bit over the next few minutes. And once you start playing with the APIs, you'll deal a lot with FHIR store. So simply put, a FHIR store is like a database for FHIR data in the Cloud HealthKit API, right? And as you all know, in traditional databases, you're storing data to a disk, and you're using something like SQL to access the data. The analog in the Cloud HealthKit API is this FHIR store, right? And the data is stored and accessed in the standard FHIR JSON format, and we support all the standard FHIR REST API interactions. And so the way you interact with this data is the standard FHIR REST API calls. So you don't need to learn any new languages. and anybody who is working with Fire can access the data in the Fire stores. And so as you go through the Buildathon over the next day or two, the way you would access this is if you're building an app, web or mobile, you can set it up so that you have the Fire stores and the HealthKit API are your Fire data backend. If you're using any of the other applications that we've seen before, you can very easily set up the Fire APIs and start using those as the data store for your Fire data. Another quick way to do it is get set up with the Fire store and the Fire APIs and use another tool like Postman or curl to start running commands. A lot of times, I think myself included, I set up my infrastructure in Google Cloud, get some Fire data in, run some Postman commands, see that everything is set up, connections are working, and then I move over to using that as a backend to my app. So there's different ways to do it, depending on how you're working with the backend data. And so with the Fire store as the central repository for your Fire data, we have a variety of different methods in the Fire APIs that allow you to both bring data in, work with the data through the standard REST APIs, but also export it out for analytics or sending to other systems, right? And so if you've got some bulk data that you want to import, let's say it is in CSV, you've got a large file of patient information coming in NDJSON, you put that file in Google Cloud Storage, and you can call a method on the Fire store that imports all of that bulk data into the Fire store. Or you can also use REST API calls, right? So you can create Fire resources, you can view Fire resources, you can search the Fire resources. You can also create more Fire stores, right? I mean, there's no limit on how many Fire stores you can create. If you want to separate your data into different partitions, you can create multiple Fire stores. There's a lot of flexibility in how you use it. In a simple use case, potentially for a Buildathon like this, you would go and set up a single Fire store, either import a file containing a bunch of data or start using API calls, so for example, the create API call to create patients or practitioners or questionnaires or whatever you need to do for the app that you're building to store the corresponding data in the backend. You also have capabilities to de-identify that data, and I'll point you to some links online. You can also set up PubSub notifications. So Google PubSub notifications allow other applications to subscribe to updates in the Fire store. So one of the use cases is your app is is creating, let's say, an encounter for a patient that is stored in the Fire store, and then you want that event to be published to another application that is watching out for that information. So you can do that with PubSub notifications. Now, another common use case is you may want to run some analytics on your Fire data. You can absolutely do that with the APIs, but think of the Fire store as a transactional application-based store. If you want to do large-scale analytics, run machine learning models, typically you would export that data into BigQuery and let the BigQuery engine do a lot of that heavy lifting. So we've got API calls for both batch and for bulk and streaming exports to BigQuery as well. So what you'll see here is just with setting up the Fire APIs and the HealthKit API, you can now use it as a fully contained backend for any of your apps that you're building this weekend and going forward. So there's a ton of information online on how to get started, how to authenticate to the API, and very detailed documentation about each of the method calls that you might need for your app. I won't have the time to go through all of it, but we have shared some links on Discord. We'll be around for the rest of the day to answer questions. There's a lot of case studies, how-to guides, and use cases. And so if you ever need help with a certain topic, for example, how do I get access tokens? Just go to the search bar on the Google Cloud website. It'll take you to the HealthKit documentation as well. So in the next few slides, I wanted to show some screenshots on how you would get set up and start using the HealthKit API. I'm going to show it for a simple use case. We've got lots of tooling on how to help organizations set up the Google Cloud infrastructure, keeping privacy, security, and HIPAA in mind. Like I said before, Rohit is going to join at 11 o'clock Pacific to talk about all the tooling and our data protection toolkit. So if you were building this as a organization outside of this weekend, or if you want to put PHI information on Google Cloud and use the HealthKit APIs, we have a lot of tools and documentation to help you all with it. So make sure you tune into the session by Rohit at 11 o'clock. So let's jump right in on how you would get started. So the basic hierarchy for these various objects in Google Cloud is at a very high level. You start with a project, right? You start by creating a project. A project is, you can think about it as a container for all the different services that you're using in Google Cloud. The Cloud HealthKit API is one of those services. But like I mentioned before, you've got Google Cloud Storage for object storage, BigQuery for analytics, and a lot of other different services. So at the very high level, all of this is contained in a project. Now, once you're in a project, you're working with the Cloud HealthKit API, and then you can define which region you want your HealthKit API and Fire data to be working on, right? And this is common with setting up your cloud infrastructure. I mean, you want your data and processing to be close to each other and in the region where you want your data to stay for regionalization compliance, for example. So you pick a region, and then you get to create a data set. A data set is a container for different data stores, right? So like Oliver mentioned before, we are working with quite a bit with DICOM images. And then we have Fire data. You probably have HL7 feeds coming in. So you can organize all this information within a data set. But for this weekend, if you're working primarily with Fire data, then the atomic unit you're working with is the Fire data store, like I explained before, right? So there's just an example on the right-hand side. For someone who's been using this for the first time, it can feel like this is a lot of information. So thanks, Ramesh, for sharing the information in the chat. We'll be around. Setting this up is really easy. You don't have to make a lot of choices, but we'll be around to help you. All right, so quick walkthrough here. So the first step, like I said, is getting started with a Google Cloud Platform project. And so the place you would start is our Google Cloud console. So it's console.cloud.google.com. If you haven't signed up using the free credits that Aditi posted in our channels, please do so. Get started. It's really easy. You just need a Google account to get started. But once you get started, you'll see one of these screens, the first screen on your left-hand side. So the left pane, you'll see your navigation panel, which is a list of all the various services. And then if this is the first time you're using Google Cloud, it could be a little overwhelming, but there's a search bar on the top of the screen, and you can use that for searching for a variety of different things. If you put healthcare in there, one of the first search results will be HealthKit API. And so use that to navigate your way around the Cloud Console. But one of the things you'll see at the top here, right here next to Google Cloud Platform, is your project selector. So I have a project selected there, but if you click on it, you will get a drop-down list. If you've already been working with Google Cloud projects, you get a list of your projects. But otherwise, you have the option of creating a new project right here. And all you need for creating a project is a project name. If you're part of a larger organization, you can do some more setup. But for now, you can leave it as no organization. Go ahead and create a project. And once you create a project, the next step is to enable the Cloud HealthKit API. You could find the Cloud HealthKit API from your navigation panel on the left here. If you scroll down, you see a section of healthcare. You could also just search for it in the search bar for HealthKit API or healthcare, and you will land on the Cloud HealthKit API page. And then you can read through the overview and the links to tutorials and documentation. But all you have to do here is click Enable. It will take about a minute or two to enable the HealthKit API. And once you do that, you'll see a screen that looks like the one on the right-hand side here. And so basically what we're doing here is I'm taking you through this process of creating a project, enabling the HealthKit API, setting a location, and eventually through about 4 or 5 clicks, you will get to a point where you have your Firestore set up and ready for use. Right? So once you enable the HealthKit API, you create a data set. Again, a data set is just a container for various data stores. So you'll see a lot of the options there. So you create a data set here. Create a data set. Again, you pick a name for your data set. I talked about location a little bit, so you can pick a region. If you're mostly based on the West Coast, you can pick US West 2. If you're on the East Coast, you can pick the East Coast region. So you're working in a region that's closer to where you are located. Now, once you create a data set, pick a location, the final step is to create a FHIR data store. And this is when you start getting into the details of FHIR. So you'll notice you can click a Create New Data Store link here. You get to pick what kind of data store you want. So you can pick FHIR. You get to pick the version of FHIR that you want to work with. FHIR R4 is the latest version. So unless you're working with legacy data, we'd recommend picking FHIR R4. And then just click Create, and your FHIR data store is ready. So it's about 4 or 5 clicks, and then you have your FHIR data store created. I won't go too much into the permission model, but there's a lot of information online. The key thing here to remember is that Google works on a role-based permission model. So every service in Google Cloud, including the HealthKit API, is protected by a set of permissions. And so an example permission could be who can read your Firestore, for example, or who can write to your Firestore. And roles define who does what, right? So you can say a particular account or a particular user can only view data in a Firestore. And so you can set up those permissions. Again, there's links I've posted in Discord. I'll also have it at the end of the slide that you can read to set up those permissions. For this weekend, we'd recommend setting up, not setting up too many of those permissions, but just as the project owner, you will have a lot of the permissions you need to deal with your Firestore. And then, so once you're set up with that, you're ready to start working with your data, right? And so if you haven't brought in any data into the Firestore, like I said, there's import functionality to import bulk data into the Firestore. We've got a method for that. Firestore.import. If you're familiar with working with FHIR bundles, we've got the execute bundle operation, so you can package in a whole bunch of FHIR requests into a single transaction or a batch and run that to bring data in, or you can send individual data. Right? I mean, if you have a app that you're building and you've linked it up to the Firestore at the back end, you can generate your patients or users or questionnaires and just start sending post requests or patch requests to create or update that data into the Firestore. And then once you have data in, you can start using any of the standard FHIR operations to work with the data. I've got some examples here. You can get patients, you can search for patients by ID or other elements of the resource. You can also get all the information of the patient using the $everything. Now, all of these are standard FHIR operations, right? These are not Google Cloud developed methods. this is us supporting the standard Fire specification. So there's a lot of examples online on how to get started with the Firestore, import data, and access data. So we've got links, and obviously we're here to help after this as well. We've got a lot of functionality around search. So once you set up your Firestores, bring data in, we support a majority of the Fire search specification. So you can search on specific elements of the Fire resource. You can also navigate references, and you can do a lot of different things depending on the application. You can use simple search, or you can also use the full power of Fire search. And then if you're exporting data from your Firestore for analytics purposes or sharing with other parties, like I mentioned before, you can do a bulk export of all your Fire data into Google Cloud Storage. The output is in an NDJSON format, so it's a series of files, and so you can use that to send to other systems. The more common use case is using it with BigQuery, so you can stream any of the changes that you make under the Firestore to BigQuery, and then use that as your analytics store or for machine learning models. One of the frequent use cases is you might be building an app that the end user is interacting with. They are adding information, they're answering, let's say, questions in your app. The data is being stored in the Firestore using the standard Fire operations. And then that data is automatically streamed to a BigQuery data set, which is powering some dashboards and reports, right? And so there you have an end-to-end application, both from an end user, but also from an analytics standpoint. So yeah, once you have your data in BigQuery, you can use standard SQL to query it, or you could build dashboards with Looker or other tools. And like I mentioned before, you can also set up PubSub notifications in case you're using other systems integrated with the Cloud HealthKit API. So any changes that happen to the Firestore are then published to a topic that you can set up in advance, and other applications that subscribe to that topic. One of the things that happens in the Firestore is every interaction with the Firestore is logged for audit logging and access transparency purposes. So in your Cloud Console, as soon as you sign up, you'll also see a section for monitoring, or you can go to it directly as cloud.google.com/monitoring. That's where you see all the logs of your interactions with the Firestore. So every operation, every interaction, you'll be able to see logs of who did what, basically with that data. So if you're running into any errors accessing the store, obviously you'll get the errors in your responses. But if you want to go check out logs, you can always go to Cloud Monitoring to see what's happening in the backend. So that's a very quick overview of how to get started. There's a lot of information online. Like I said, you always start with the Cloud Console. We have quick start guides on both getting started with Google Cloud, if this is your first time working with Google Cloud, introductions to the HealthKit API. If you're building an app, how do you authenticate to the HealthKit API backend? How do you get your access tokens, for example? We've got a lot of information there. And a lot of detailed information on the specific methods that you can use to interact with the Fire APIs. Again, if you're not finding what you want, ping us on Concord. You can use the search tool on the Cloud HealthKit API's website. If you want to integrate with BigQuery, if you're using analytics, we strongly recommend checking out BigQuery as well. There's a lot of how-to guides and quick starts on BigQuery as well. So that's the end of my presentation. If you've got any questions, we'll be around. You can post it in our Discord channel. If you want to reach out after this presentation as well, we'll post our information in our channel. Dharmesh, myself, are always available to help developers get started and get using with our Fire APIs.
All right, thank you both, Kailan and Dharmesh, for that. I mean, what an incredible set of tools that you've built, and it's, you know, you made it also, again, really straightforward and you know, to implement and use. So thank you also for sticking around for the office hours. What I think we'll do, we have about 4 or 5 minutes. We might as well take a short break. The next session at 10:30 is going to be from Alex, and he'll go over Firebase. So let's do that. We'll take a short, you know, 4 or 5 minute break. And Amir, I don't know if you're on. Maybe we can start the reel. All right. See you, everybody, shortly. Thank you. And again, just one of those amazing tools to really make it straightforward to, you know, develop in a mobile with a serverless kind of backend. So welcome, Alex. Definitely introduce yourself as well. We're excited to have you. Thanks for joining.
Hello again. I am Alex from Canada, actually from nearby Toronto, and so it's a really nice afternoon here, sun and everything. And if you were on my previous presentation yesterday, you probably heard that I'm a software engineer. I mostly specialize on front-end software engineering, that is everything that has to do with app and mobile app, web development, a little bit of IoT as well. And also ML is one of my long-term passions, even though I haven't really gone too deep into it. I should be happy to actually answer any questions around applications for the ML models that are either already natively supported in Firebase, as well as the one that come with GCP and are not directly integrated. I should be able to point you in the right direction should you have any questions. Now, I'm not 100% sure exactly what is the skill level regarding ML for the participants, so I'll start with very basic introductory things, and then I will slowly go into more complex context as we go through the presentation. Okay, so let's start with a very basic thing. Essentially, what's ML? Well, technically, ML, AI, linear regression, statistical inference, data science, they have a lot of overlap. So a lot of the time when people say ML, or they say AI, or they say data science, actually mean the same thing, and they mean having some kind of model to answer a question based on some data. And these are usually useful when we can't effectively express that through code. So whenever we have a deterministic problem to solve, that is, we know how to compute the exact using a formula from an exact result using a formula from an input, that's when we usually do software engineering. And when we don't really have that formula, and the result cannot be expressed easily as a deterministic problem, then that's where ML is especially useful. So if I were to quote here Arthur, the field of study that gives computers the ability to learn without being explicitly programmed, that is, the ability that gives the computers a way to find answers that are not necessarily deterministic in our view, is what machine learning is about. Okay, so as you can probably figure out by now, the main difference between a classical programming model and an ML model would be the way we create it. With the classical software program, we'll just go ahead and write some code, and depending on the logic, it will output a result. With ML, we don't usually have a way to express the program. We might have some restrictions, some parameters, or some preferences that we set when we define the model or its structure, but we don't really have a way to express it in form of instruction. Instead, we give it data. Usually the data comes in samples. Sometimes we also give it an output. Sometimes we don't really know what the output should be, and we might actually ask the computer to come with some ideas, and then we would go over it and try to make sense of it. Anyways, if I were to boil down it to a very simple concept, it's data in, some input in, program out. Okay, so some of the most well-known applications are computer vision, which is also really useful in medical field, particularly around medical imaging, as well as for making sense of the huge amounts of data that a lot of the times are not stored in the same format, or they might have inconsistencies. So computer vision can really help us remove a lot of the manual work of sorting through images, or going on trying to pinpoint some specific features which might be really, really hard to notice with an untrained eye. A second really useful application of machine learning is personalization. Essentially, we would have a bunch of possible interpretations of content or things, and then we would recommend just a few that we think would be most relevant for that particular case. While the classical use of personalization is around marketing and social apps, it can definitely be used in the medical field as well, particularly when we have a lot of possible things and outcomes, and we want to limit that number to a more manageable amount for certain user, or for certain study or scenario. And probably this will become more and more useful as more data, as more medical data is actively being managed. Okay, one really cool thing about ML, which in the last 5 years really hit the really got to the edge of being almost undistinguishable from natural speak is the natural language capabilities of machines. Of course, it's the first thing that comes to mind is natural language translation, and that is can be really useful in the medical field as well. There is already a pre-trained medical translation-based model that can be used in Google Cloud, and Firebase can help you just use it, get to use it a little faster. For instance, if you have some data coming in from an app, Firebase can be the bridge in between your data inputs, the code that runs the actual translation, and then the output of the data. So Firebase can really be a tool to save you a lot of time to just bringing everything together. Other than this, there is also AutoML around translation. So if you have a really specialized knowledge, yet again, you can look into the Cloud ML, and then Firebase might be the glue to make it more usable in the field. So this is probably one of the really cool things that might be out there for you. Unfortunately, you'll have to do a little bit of manual work. It's not directly integrated with Firebase, as you will see later on, but it's still very possible to use it without much effort. The next thing that is also quite common is sentiment analysis, and these might be actually useful in field. Yet again, there's some room to experiment and see if this can improve the collection of data. For instance, things like sentiment analysis or face tracking might be used to just pre-validate data before collection, so that you don't have to retake screenshots or maybe ask for repeated data because it's not high quality enough. Having these models deployed, some of these models deployed on your customer devices, can really speed up data acquisition. And I'll talk a little bit more about this when we look at the actual example of deployed model. And a third one would be entity extraction for natural language processing. Yet again, it might be really useful, especially when working with big corpuses of data, especially if the data is highly specialized, custom trained models over specialized text bodies can really help out make sense of data without having to spend lots of resources through just going manually through it. Okay, another really cool application of machine learning is content generation. These networks are usually generative adversarial networks, and as their name implies, there are two networks, one of them trying to generate content as well as it can from a preceded sample, and the other one will try to figure out how well the content looks, essentially how natural it seems, and then give some feedback into the first network. These are mostly used nowadays. They're mostly used for as an aid for creatives, as well as in some marketing and PR workloads. Particularly, you might have heard about the deep clones, in which a person can be impersonated and as if they were to deliver a certain talk or behave in a certain way, while really it was just a computer-generated behavior based on a model of that person. It's one of the fields that is really developing very intensely right now, and there's very good progress in this field. So definitely take a look and try it out and see if maybe that's something useful for you. Okay, so now that we looked at the types of the base types of machine learning, let's look at where these models actually being executed. Okay, so there are essentially two places where these usually live. First one would be in the cloud. The second one would be on premises or at the edge or on device. All three names pretty much mean the same thing. A lot of the times, there are also mixed models being used. So, for instance, the on-device model will be used initially to just assess the quality of data, maybe, or try to process the data and see if it can extract features on its own. And if it fails, it might ask for help from a more complex model in the cloud. Also, this might happen. This might be used if the device is offline, and then when it goes back online, it might also ask for help from the cloud model. Firebase supports both of these, and we have some boilerplate code that makes these integrations simpler, essentially allowing you to decide how you want to run a model, and if you want to fall back to a local model when the internet connection is not available, and so on. Okay, now why would you want to actually run a model on device versus cloud? So the main reason to run something at the edge is when you're concerned about when you're concerned about some of the things in this slide. So for instance, if you need a faster latency than what the cloud is able to provide, if your model needs to send a lot of data in and out in order to do any useful work, or if the data is private and you're not allowed to send it to an external party or to the cloud. So these might be the main reasons to have the data on the device. Also, sometimes you might need to couple the data with sensors. So yet again, latency becomes a really important thing here. There's also some reasons to send it that you might want to send it in the cloud, particularly if your device is power hungry and your battery is not big enough to accommodate the workload all the time. So really, depending on your use case, you'll decide how to use it, and Firebase might help you in both cases. Okay, of course, there are a couple of challenges, and let's talk a little bit about them and see how Firebase tries to help throughout this throughout this life cycle of ML model. So first of all, it's identifying a business problem. Here, you probably already are doing the brainstorming yourself. One thing that we might help with is just having these pre-trained models. So it might be a good way to inspire you, to show you what's already possible, what's already easy to do, so that you have a really good grounding on what's the current state of ML. Generally, the stuff that we have in Firebase uses cutting-edge models. That means that the models that we use were probably researched and developed a few years back, and then they were recently productivized, and they're still being maintained and improved. Next is data gathering. Yet again, here we try to provide a little bit of guidance. Google Cloud does the same thing. It will try to provide you some guidance around how much data you actually need for your model to be efficient. And if you look through the documentation, it will actually give you some numbers. For instance, it will tell you that you need around 1,000, at least 1,000 sentences in order to train a custom translation model, and you maybe need at least 100 images for a certain class of image classifier, and so on. Just look through the docs. It should give you some idea of the order of magnitude of how much information you need. Once you know that, just go ahead, gather it, and try to make it good quality. There's a bunch of articles out there. Unfortunately, we cannot help you make sure the information is good quality, but you'll know that it is good if the testing phase passes with good results. As long as your training and your testing data sets are both randomized and they don't overlap. Okay, now training, tuning, evaluating model, that's where Google Cloud and Firebase actually shine. They try to automate as much as possible around this step, and so that you don't have to spend additional resources doing this work yourself. Sometimes you'll still have to do a bunch of it yourself, particularly if you're doing research. You still have to do the research portion somewhere else. But once you have a model, or once you know what kind of model you want, if you can find it, then we really take care of a lot of the automation around here, as well as on the deployment and implementation side. Yet again, we have production-ready resources that should help you deploy the model both at the edge and in the cloud. Okay, so yeah, let's look at the specific, the actual map of our services and where Firebase comes into play and where Google Cloud comes into play. So we essentially have these three three big technical pillars, which describe the type of technical problem we're trying to solve. So the first one is a pre-trained model. So pre-trained is an excellent solution when you're trying to solve a problem that was already formulated or has already been solved by someone, and you just want to streamline your workflow. For instance, you might want to do some image processing with standard feature extraction, or maybe you want to do some text processing with generic computer natural language processing features and so on. So pre-trained things is one of the things where we shine, particularly for a few of the really common use cases. Hopefully, this will help you to get the data faster and make sense of it faster. The next one is the service layer. Essentially, that's where you have a little bit of customization over your models. It allows you to train your so-called custom models and serve them to the users. But at the same time, you still build on top of the know-how of Google. So essentially, you don't have to come with your own model configuration yourself. You just take one model which is already performant and ready for production, and you just feed it some training data that is specific for your field or for your niche usage. What happens in this custom model training process is the model usually is just the last layer or two of the model being retrained. Normally, the model will have several layers of that would be interconnected at some points. And normally, when you train something with AutoML, what happens? You're essentially retraining just the last few layers. This way, you save a lot of time on not having to train the first few layers, and you also don't have to really design the entire model yourself, which is probably your go-to solution for most of the hacks, in my opinion. Essentially, the workflow will be like this. See if you can use anything that's pre-trained to just simplify your workflow. Then look what you actually want to build and see if you can do it with a custom model that uses a base model for training. And if that is not possible at all because you're maybe in a cutting-edge research field, then you essentially have to do custom models. And yet again, custom models can come in many different shapes and at many different levels. And what we can do here with Firebase is essentially just help to deploy and productivize that model once it's built. So once you have some results and you're happy with what you achieved, then you can use Firebase to do things like deploying it on your in-field devices. You can control which model to be used by using, for instance, remote config, and you can also experiment with some A/B testing also in field. So really, this should help you figure out if your model is working efficiently in field, not only in the research laboratory. Okay, the second thing that Firebase can help you with is for certain specific model, we also have an UI to help you with the training portion. But there's not really a lot there. Like the training process is probably better handled by better handled by tools that's specifically created for that. Okay, yeah. Now let's look at each of these. So how can we use Firebase? What can we use Firebase for? Okay, yeah. Let's start with. I'm not sure why this one skipped. Okay, so yeah. So there are three models that are pre-built in Firebase that you can deploy, that you can use directly from within the SDK. It's text recognition, image labeling, landmark recognition. What does this mean? It means you don't really have to write almost any code whatsoever. You essentially just give a few lines of code to provide the data for this model to work. You enable it in your console, and that's it. It just works. These are the in-cloud models, and there's not a lot of them which are configured with Firebase, but don't worry. For most of the other stuff, you can still do it with a little bit of custom code. And what would a custom code look like? So anytime you want to use a model that's an API or a model that's not supported natively by Firebase ML, your workflow would be pretty much like this. You would create an entry somewhere in a database, usually that would be Firestore, in which you'd put the parameters and the inputs that you want for that model. If your input is a bigger binary file, for instance, an image or a video, you'll probably also be using storage. Anyways, once you have that entry in, you would want a cloud function to hook up and be called whenever you create that document, and then call an API from Cloud AI or any other third-party provider that would run your model. Probably the only thing here to keep in mind is that you'll need to enable and configure the Cloud AI APIs separately. So once you'll have to configure the Firebase portion, you'll also need to configure the Cloud AI API. But once you've done this, it should be very straightforward. And most of the cloud APIs actually provide some kind of SDK or library for usage. For instance, most of our Cloud AI APIs provide Node.js libraries. So all you have to do is just import it in your cloud function and call it using the documentation, and it should just work pretty much from the first try. If you want an example of how to do that, you can take a look at one of the really cool blog posts or at the translation extension that we have in Firebase. Okay, now there's also the on-device models, and right now they come as a separate product. They used to be part of Firebase. Now they are a separate product. They still kept their name. They're still called MLKit. And these are all the on-device models that you can use and that are ready for you to deploy. Each of them has a getting started guide, which just walks you through the steps. And these steps usually consist of two things, generally. The first thing is just getting the libraries, configuring your client application, and the second one is getting the model, fetching the model on your device from where it's stored, and that's it. Once you have this, all you do you call the API that you just installed, and you should spun out results in an easily to understand format. The main advantage of using MLKit versus calling your model directly is that it has nice native programming interfaces for data input and output. So you don't have to be as careful with correctly defining the input and output parameters. There's a lot of boilerplate that's already done for you, and the code just looks so much cleaner. Okay. There are also a few natural language APIs next to the Cloud Visions. I would just encourage you to check them out and see if there's anything that can help you. And if not, don't fear. We still have many other ways to call these APIs from Firebase. And the workflow will pretty much be like this. Depending on where your model is stored, you will have a few options to call it. And probably the simplest way to call it would be to actually use Firebase ML to store your model and optionally deploy it on the device. Okay. And in order to do that, you generally have to export your model into a TF Lite format, and by converting it to Lite, you can decrease your binary size enough so that the model will run on your mobile device, and then Firebase will just take care of hosting and serving the model. So when would you want to actually use this custom model deployment workflow? It's essentially whenever your model still has good performance after being compressed into a TF Lite model. So take your initial model, do some benchmarking, see how good it is, then export it as TF Lite and do the benchmarking again. If you're happy, then probably your model is ready to run on your on-premises devices, and then go ahead and try it. If you're able to run it on the devices, that all of those benefits that I listed before, that might help you get the results faster. If that does not work, then you still have other options to do it by running it in the cloud. Okay, now the third thing that Firebase can help with is the AutoML model training. This is usually useful for models. This is generally useful for models that you might want to run both on device using the TF-Lite model, but eventually you'll see that you can also, maybe you might also want to use these models on the server as well. It's up to you. Essentially, what AutoML does is allows you to get a bunch of data. In the case of Firebase, we only support images at the moment, but Google Cloud also has support for a few other use cases. And what happens with AutoML is you provide these images for AutoML, Firebase AutoML, you have a really nice interface for this. For some of the other AutoML stuff, the interface might not be quite as easy to use, but the workflow would be very similar. So if you, once you do this, if you try to use AutoML with something else, it will just feel natural. So you should probably be able to do that from the first go. Yeah. So how do you do this? You just provide the data. You provide some parameters. Essentially, just tell it how you wanna group the data. In case of pictures, you just group them by folder. That's how you assign labels. And then the model will spit out. This training will spit out a model that can be deployed on the device for you. And Firebase takes care of 90% of all the work involved. Now let's look at a few examples. The first example would use a custom model deployment. So let's imagine we have we found out about Teachable Machine, which is a really great project to play with. So we use our webcam. We recorded a few images of a certain object we're interested in or a certain pose. Then we export the TensorFlow Lite. What do we do next? Well, here we can use Firebase to just push it on our phone, and after that we just call that model, and it will spit out one parameter which will tell us if the label that that model thinks your picture is representative of. I really encourage you to try out Teachable Machines if you haven't worked with AutoML type of models before. You should really shed a lot of light on what it is, what it's supposed to do, and what are the basic capabilities of this family of models. Okay, of course, for a more advanced use case, you can you can use the AI platform from Google Cloud, and Firebase will just take care of some of the deployment steps, particularly if the deployment is done on iOS or Android devices. For other kinds of devices, there are options directly in cloud that can help you with the deployment as well. Another use case would be, for instance, to use AutoML to quickly categorize data as it's being intaken in your app. For instance, if you have a good collection of labeled images, you can just use AutoML. And eBay, for instance, use that to train a model for sorting their pictures by type. For instance, exterior, interior, or drivetrain pictures. In a similar way, you can sort pictures in a study group or in a customer profile to remove the ones that are not relevant, or to extract only the ones that are interesting for processing by another model. Okay. If you're curious to see how to call an API using Cloud Functions, there are a few really great articles on Medium. This is one of my favorites because it shows how to very simply build an iOS app which uses two AI APIs that are not natively supported by Firebase ML by using a Cloud Function as well as a Firebase extension. So it really gives you a good understanding of what your workflow might look like. It employs both Firestore and storage, so it covers a lot of ground. Okay, probably Another kind of model that you might find useful and pretty easy to do with Firebase would be to just build an AutoML tabular model, spreadsheet model with Google Cloud. It provides a really nice interface which can help you either forecast a value or categorize items. And once you have that model configured in the Google Cloud UI, you just export it as a TF-Lite model, and then you can deploy it on your devices, and Firebase will help you with that. Okay, so that's really all I had to say today. I hope it wasn't. I hope the middle portion was not too overwhelming. But feel free to ask me questions later on. I'll also post a few links on the in the discussion group on Discord, so that you have those links to the things that I referenced in today's presentation. And I think it will be so much more clear how all of this works once you just see the step-by-step guides in those articles and help documents.
Thank you, Alex. That was a really, really great overview, starting from fairly basic to more advanced. And I have to tell you, I've used. I'm not a software developer, and I was able to use. The UI was so straightforward that I was doing this wound infection project where I had photos of infected wounds and photos that I had labeled with what characteristics they had, and provided a table, and just fed it to AutoML, and boom, had my result. It's just incredibly powerful. So thank you for sharing, and I just can't emphasize enough how great the tools are. So I really appreciate your presentation and being around for question and answer on the Google Meet, the separate Google Meet. So that's great. So now we're fortunate to have Rohit from Google Cloud join us as well, and he's going to talk about the Cloud Data Protection Kit. And thanks for joining, Rohit. And maybe you could start by introducing yourself, and then feel free to share your slides.
All right, thank you very much. Yes, my name is Rohit Talreja. I'm a product manager on the Google Cloud platform, specifically our healthcare and life sciences team. And I have been at Google for about 4 years. Before that, I have a background in both AI and healthcare, including some studying at Stanford back in the day. So this is a fun event to tie everything together for me personally. At Google, I've worked kind of on our security, privacy, and compliance teams, as well as our healthcare space. So today, I guess the talk I'm giving is about our approaches to security, privacy, compliance in the healthcare domain, and ways to kind of make it easier for everyone as they build both applications today and any sort of production applications in the future. So my team's goal really is to take in the regulatory overload, or the regulatory burden that exists in healthcare, and try and simplify it where possible, make it cheaper, faster, more streamlined to meet regulatory requirements while trying to do data analysis, AI, or clinical care projects in the cloud. So what we use as sort of our driving goals is to take the amount of money that's spent in the healthcare system, about $39 billion a year on administrative and technical activities related to compliance, and try and reduce that, right? Take the clinician impact, which is about 50 or 60 full-time employees, maybe in this between 10 and 20 medical staff, right? Doctors and nurses, and try and reduce that. And then also the end goal, I think for everyone, right, is to make the patient experience better. And by reducing the amount of money and time spent on these regulatory activities, we free up more funding and resources for research, for clinical care, for patient experience, and what matters at the end of the day in the healthcare system. The context that we work in healthcare is there's a lot of different constraints around how data is stored, processed, leveraged for AI, ML, or analytics workloads. And it comes from a number of different places. I think everyone has the idea that healthcare regulations are complicated, but not everyone really understands that it's a very nuanced set of constraints, rather than it just being a binary, oh, you're in healthcare, so it's complicated. One of these sets of constraints comes from data privacy regulations. I think most people in the US who are working with health data are familiar with HIPAA, usually through the form of the annual training your organization will make you go through to say, okay, we're compliant with the HIPAA regulation around use of protected health information. And then obviously what has been kind of hot news in the privacy space for the last several years is GDPR in the European Union, which again has a similar set of constraints around how personal data is collected, processed, transferred between organizations, and so on, right? So these are legal requirements. They have fairly strict penalties, but they don't generally have strict definitions about what is or isn't required. It's more of intent matters. Phrasing matters quite a bit. So these are meant to be time agnostic, right? So as the technology evolves, these standards and regulations are meant to stand the test of time. Then you get frameworks from governments, which are either sets of guidelines that national governments put out for their healthcare and life sciences industries, or in the case of the ones listed here, they're kind of contracting frameworks that you would use to engage with US government agencies. So if you're doing any work with the VA in the US or the NIH, FedRAMP will come up quite a bit. So it's often a sort of overlap between the government contracting space and the healthcare space. Next, we'd get industry standards, and these are more for production applications, more for business to business use cases. So there's a set of industry standards for healthcare that govern IT operations, security, privacy, incident response, data resiliency, data availability, so on and so forth, right? So these are, in contrast to the previous two, a bit more voluntary, in that nobody is going to force you to go and get certified against one of these standards. However, it's usually considered sort of a cost of doing business, right? If you want to work business to business in healthcare, you'll probably come across one or more of these requirements from your collaborators. And finally, in the kind of pharma, drug development, life sciences, and medical devices space, there's a very large set of regulation that's referred to as GXP. And GXP stands for Good Blank Practices. And when they say good practices, it's a combination of regulation, such as from the Food and Drug Administration in the US, or similar regulatory bodies worldwide. It's industry standards. It's a bit of knowledge specific to the organization, or other controls as kind of a catch-all to make sure that data is treated appropriately. And you can get GXPs for a number of things, right? It's clinical practice, it's laboratory practice, manufacturing practice. So when we have these big news articles about how certain labs are not following protocol, or being shut down because their accuracy results have kind of been thrown into question, this is usually the space that they're talking about, is they haven't followed the appropriate GXPs to ensure that their tests were repeatable, had the data integrity to avoid being tampered with during the research process, and so on. So, how does this kind of all come together and make a productive application environment, a secure application environment? So the way Google Cloud has kind of bucketed it is to bucket it in sort of three ways. And not everything fits cleanly into these three buckets, but you can think of things as being either just fundamental data protection capabilities within the core platform. And these are things that are kind of done by default by Google, and all of the users can kind of benefit from it. There's this middle bucket of here are the controls that we've enabled users to use, right? So these are kind of the optional or configurable security and privacy settings that help them meet their specific needs for the given project. And then the last bit is sort of the wrapping documentation. It's kind of our compliance certifications, attestations, things that we use to make the purchasing process easier, or easier for our users to document how they're meeting, you know, one of the regulation standards or frameworks that I talked about earlier. So the things that Google has tried to do, and especially for healthcare, right, where there is a kind of need to innovate quickly but also securely, is build in as many capabilities into the underlying platform as possible. And we do this taking a defense in depth approach. So if you think of the traditional security model that, you know, was popular maybe a couple decades ago and still kind of has a footprint in healthcare, it's what I would call the perimeter defense model. You know, you would put a very thick firewall around the organization, have, you know, authentication for that firewall, but really once you got inside the perimeter, everything inside wasn't really further protected, right? So the analogy that's used often is an eggshell. So if you have a thick shell around the egg, it prevents a number of attacks, but once you get into the inside of the egg, everything is gooey and squishy, meaning the attacker can just find whatever they want and exfiltrate it out without a problem once they've breached that perimeter. So in contrast, the defense in depth approach that's employed here kind of treats the IT stack as both as a spectrum, right? So there's a spectrum of capabilities going from physical infrastructure to virtual infrastructure to internet connectivity, and then identity on the top, or sorry, operational and device identity on the top for the end users. There are specific protections that are in place in each level of the stack that are designed to protect against the types of vulnerabilities that can only be, you know, exploited at that layer. So an example of this is at the storage layer. Data is encrypted at rest by default, and this is something that Google does across all of the services, across all of the users, without any configuration, right? Just because we fundamentally believe that encryption is a good way to protect data at rest. It's not the only way to protect data at rest, but it's one of the good ways. So we have just implemented it by default across the board. And this is, you know, in contrast to a traditional IT stack where every customer would have had to implement their own form of encryption. You know, as the saying goes, don't roll your own crypto. This is kind of taking that to an extreme, right? And Google just giving everyone a baseline level of cryptographic security on the data. There isn't really enough time for me to talk about all of the functionality in detail, but, you know, safe to say that there are a number of different protections in place across that defense in depth stack that I mentioned, and all of these are kind of running at the appropriate times, at the appropriate levels of the process for healthcare and life sciences organizations, and for all cloud users. All right, so where this becomes interesting, we think, to healthcare organizations is the shared responsibility model. And this is the idea that, you know, in contrast to a traditional IT infrastructure where the data center owner or the shared infrastructure owner was responsible for doing everything top to bottom, in the cloud model, there is shared responsibility in the sense that the cloud provider, in this case Google, is taking a fair bit of the effort and cost and responsibility for protecting certain levels of the infrastructure. And then it is up to the cloud user to only protect the remaining portions. And we find that this, you know, model is especially welcome in healthcare, again, right, where there is a cost crunch, where there is a bandwidth crunch in needing to do multiple things with limited resources. So the cloud model is especially helpful here. I've broken this down into a few different segments to kind of highlight the trade-off between control and shared responsibility. So if you look at the the infrastructure as a service example, which is our virtual machine engine or compute engine, Google has taken on infrastructure and kind of virtualization responsibilities. So we've deployed the hardware stack. We've installed our proprietary hardware and software at the physical layer. We've virtualized the machines. We've enabled encryption by default, and we've turned on audit logging by default. And then the amount of control that's afforded to organizations is kind of everything after that, right? But with that control comes the responsibility to do it correctly. So you'd be responsible for provisioning the appropriate images, firewalls, authentication, and so on. If you contrast that to a platform as a service, Google has gone further in this regard in terms of taking on responsibility for load balancing and provisioning infrastructure and auto scaling, but also on the security side to managing more of the network security, the firewall rules that no longer are visible, right? So the customer IT responsibility has decreased, but in a way a little bit of the control has decreased as well, right? So that's kind of the spectrum and trade-off that this operates on. And at the far end of the spectrum, Google Drive, the shared responsibility here is actually fairly minimal on the user side, right? It's basically just provision the users and what they have access to within the organization. And the way this gets kind of employed most often within healthcare organizations is to think about where is control needed versus where can control be abstracted in the interest of simplicity, and that's kind of the model that's used. So as you think about what projects and how you build and configure them over the Buildathon and beyond, I encourage that as one of the criteria to consider is are we okay just treating this as a somewhat of a managed service or a fully managed service, or not at all a managed service compared to what we need to secure and build on. All right, so for the control aspect, there are again a number of controls aligned to the similar defense in depth model that I started at the beginning, in that you need to be able to protect the application at levels of the stack where the vulnerabilities are most likely to occur, right? So there are network attacks that we have network protections for. There are identity facing attacks like phishing that are protected for at the identity layer, and so on. All right, and then the last bit, just kind of touching on this, right? So compliance is not the be all and end all when it comes to security and privacy. It's a very useful way to document capabilities and attestations, but it is not it's not meant to be seen as the best an organization can get. It's a very good starting point from which to have discussions. It's a very good baseline. But the defense in depth model creates kind of a common control framework that allows organizations to meet a number of these requirements with a single implementation, rather than having to do unique implementations for each framework that they participate in. All right. So for the remainder of the talk, I'll talk more about some practical capabilities that my team has designed and released to the open source domain about how to quickly get secure private projects on Google Cloud up and running for healthcare workloads. And by this I mean there's a workflow that we find users going through is they need to deploy the application resources, monitor for drift, audit any drift that occurred, and then prevent similar issues from happening in the future, right? And this is for a couple of reasons. I think first, it's good practice when working with sensitive data or IP to have kind of a governed process in place for managing resources, and also this process also helps get up and running quickly. Is like when you have a good amount of automation in place, You can get a MVP stack or even a production stack up in a fraction of the time that it would take to do it by hand. So what we aim to do with this is create this end-to-end toolkit, which we call the data protection suite or the data protection toolkit, to help organizations deploy kind of templatized infra as code workloads, have automated continuous monitoring and validation, and then have a manual surface in which to do auditing against their security requirements and compliance requirements. So the way this works is we've published what we call a number of templates, and these templates, and I made some of them available on the Discord channel. These templates kind of define baseline infrastructure. So if you want a data lake infrastructure in BigQuery, or you want a HIPAA-aligned infrastructure for an application backend, so some backend on cloud that's going to serve as a backend for a mobile application. We have sort of these pre-built templates in our library that create the appropriate infrastructure, the appropriate IAM and ACL settings, the appropriate firewall rules, etc., just to get you going from a place of safety, if that makes sense. And these templates are extensible, configurable. You can mix and match two together or N templates together to get a larger and larger project. And then finally, Terraform, which is an open source infra as code utility, gets everything deployed onto GCP. So when I say it's a extensible template, what do I mean by this? Is we've defined these sort of deployment templates to have modules, right? So this module right here is setting up our data warehouse BigQuery for an analytics project, and some of the configuration options that would be present here is things you'd expect, like names of the data set, the project, etc. But also, things that have sort of these security leanings, right? So it's what's the data retention and data lifecycle policy look like? Who should have access to this data set? What access should they have? Data owner, somebody who is able to fully manipulate the data and edit it and so on, versus who should have this view-only access, right? For people maybe in a different team or a different organization who shouldn't have the ability to modify the data, but may have the ability to read it. And with these modules, we kind of successfully build up larger and larger projects to do more and more complicated things. Within these templates also include automated monitoring policies. So the monitoring policies can be set up in a similar declarative syntax. They run at kind of defined intervals or even continuously to pick up any deviations from how you want the project to be configured. So we have monitoring policies for some organization-wide things like network policies or ACL rules, but we also have policies for very specific things like which APIs and services should be enabled, how should encryption keys be managed and rotated, how should the data lifecycle look for a particular storage service, and so on. And finally, tying everything together, it's the visualization piece, or what we call the auditing and reporting piece. And here our data protection dashboard enables users to visualize their policies, visualize their environments, understand the security and privacy and compliance posture of the workloads, and then be able to dig deeper into any sort of issues that have occurred or issues that have been detected from the scanning tools. And what this does is it puts the governance lens on top of the workload and say, okay, we have a workload that's running in our dev environment, our staging environment, or our prod environment. We understand how it's supposed to be configured versus how it is being used. And tying it all together, and I think this is something that may be useful to some of the teams here this weekend, is using one of our automated HIPAA-aligned deployment infrastructure environments. So this is something that sets up baseline infrastructure and controls on GCP around data storage, data processing, import and export, and then also sets up kind of a connection layer to off cloud or third-party services like an on-premise service or a third-party cloud stack. And this is just something that can be deployed in about 10 minutes, 15 minutes, and gets a lot of that fundamental deployment layer out of the way, so that then you can start dropping in your specific analytics workloads or specific AI ML or workloads or app backends just kind of on top of this or within this security model. So kind of leave with the conclusion here, which is just, GCP's has a number of capabilities across healthcare, life sciences, security, and privacy. The data protection suite is one way to kind of accelerate getting workloads on cloud faster and pre-applying some of these best practices. But at the end of the day, everything is still fully configurable and extensible for you to take advantage of all the benefits that exist. So, with that, thanks for joining in the session. Hope it was informative or useful in some way. And I'll be sharing some links on the chat channel here as well as in Discord, including the link to the Q&A session that will follow this. Thanks.
Thanks, Rohit. That was fairly extensive and really impressive how much work you've done. And we know Google works with health systems and so on, so you've had to do a lot of serious work. I really love the highlighting again the shared responsibility that's kind of expected and required to deploy one of these correctly and to do it right. And then I had a question about I don't know if this is the right forum or right time, but the automated HIPAA deployment.
Sure.
Is that something that is in beta or?
It is a good question. So it is an open source and a stable open source version. So I have some kind of links in the Discord channel, but I can re-ping them around. But basically, what you would do is you would go to our kind of GitHub repo, pick one of the starter templates that best suits the environment that you're looking for. We've got some around GXP and pharma med device workloads. We have some around kind of traditional HIPAA, data, AI, ML workloads, and so on. And then that's kind of the starting point for a larger project, if you will.
I mean, that's fantastic. Again, just tools to make it easier and easier. So we're still going to have, if you're available, there is a Google link for you to, if you're available for some office hour time, a separate Google link. It'll be in the chat here and also in Discord and the announcements channel. And then for the last session for today, we're going to have Andy Chang from Google as well, who is going to talk about cloud security. Thanks for joining, Andy, and we'd love to get an intro. If you could stop sharing, Rohit, so that Andy could share. We'd love to get an intro first from you, Andy.
Great. Thanks, folks. I'm Andy Chang. I'm product manager on the Google Cloud Security team. Been with Google at this point now 5 years, working on threat detection, security, and response. And really excited today to talk to you guys about how, as Rohit talked about compliance and talked about the different things folks can do as they think about meeting kind of the regulations of doing biohealthcare workloads. I'm going to take it from a different side. What we think about on the security side is how to really detect threats, prevent breaches. And so for production workloads, in addition to the items that Rohit talked about in open source, we've built managed services, including the Cloud Security Command Center. It's really about having production, and you have production workloads across multiple projects, multiple accounts. How do you actually prevent threats and also detect threats and then respond to them? So, at a very high level, what the problem we're trying to solve for customers is really how do you see and manage your security posture, prevent bad things from happening across all of the projects in your full organization. And so this is really directly relevant for folks who are at the security side of administration across the multiple research groups and teams that are working on Google Cloud in your organization, and also for the developers that are running end-to-end organizations for the purpose of their particular kind of healthcare or bio programs. We also, as I think was mentioned earlier, there's a Discord channel dedicated to this. I've already put some links in there, and we'll be responding to questions in that throughout the day, as well as post this. There's a Meet office hours that I'll be hosting. So, at a very high level, one of the goals of moving to cloud is to allow developers, whether it's in healthcare or in other disciplines, move fast, do things at scale. Right? And that's a huge benefit for public cloud. One of the challenges on the security side is that creates an ever-expanding attack surface as deployments get more and more complex. Really understanding what has been spun up, where are the points that are potentially weak that a bad guy would try to go and intrude into. That's an increasingly hard problem. And one of the key reasons we have the Security Command Center is to allow organizations, security administrators, yourselves as developers, to see that full surface area as you start building more and more things in a managed, automated way, so you don't have to go out and find where new resources have been spun up that potentially now are attackable. It's all covered in one surface, both UI surface and API surface. So as we think about this, the challenges that customers face ultimately are really focused around three things. As folks are used to building things out in their own on-premise deployments, they're used to a certain level of visibility, a certain level of control. I think as Rohit talked about on Google Cloud Platform, we've actually created a whole set of defense in depth controls at each of the levels so that you can, if not directly replicate the security control and visibility that you already have on premise, you have the ability to find either compensating controls, potentially substituting better controls to underlying built in the platform. So we take that responsibility for you. But when folks are moving to cloud, they care first and foremost, do they get the visibility and that ability to assess posture that they're used to? And then the next piece is, that set of confidence around, can I find and continue to detect and respond to the types of threats that I'm used to being secured against when I'm on-prem and in more control. But as we talked about in the shared responsibility model, when you've now moved into public cloud, we as the cloud provider are empowering you with additional tools to get you that level of detection response capability. And as I mentioned earlier, one of the benefits that everyone is moving to cloud for is that velocity, that scale of resources that you can now deploy with a click of a button. For security admins, for folks, security researchers and security analysts, that dynamically increases the complexity of what you actually have to protect the organization from. And so these are the three things that when we've built the Security Command Center, the purpose is to bring all of that into one place so you can in fact stay in control of the security of whatever you're running on your Google Cloud organization. So the Security Command Center provides you that single place for control across your estate on Google Cloud. It's really that unified set of capabilities, prevention capabilities, detection capabilities, response capabilities that you manage in one place, giving you that organization-wide visibility, detection and response. And it enables you to take a lot of the native Google Cloud security expertise and capabilities and leverage them and manage them in a consistent manner. So as we think about what it is and what Security Command Center and Security Command Center Premium are, Security Command Center really gives you, as we said, organization level visibility and assessment of your security posture, prevention of threats through compliance checks, security monitoring, continuous and near real time, and the ability to now give you guidance about what you want to do once you find an issue, whether it's a vulnerability issue or a threat issue. As a part of the threat side, we naturally incorporate the threat expertise and threat intelligence that Google leverages built into the Security Command Center to allow you to detect threats against your own cloud assets. And since it's a Google operated service, it scales naturally as your deployment scales. We launched the original version of the Security Command Center back in April 2019, and last week launched the Security Command Center Premium product as well in GA. So now both the original Security Command Center product is in GA as well as the Command Center Premium product. So first up around this is really the organizational level control, right? That ability for you to have a single consistent place for you to enable the services, to enable what they operate on. And so as you think about the range of different types of detectors, Google security services, having that central control place to say, I want to enable vulnerability detection on these set of projects, I want to enable threat detection on these set of projects, I want to enable certain compliance assessments only to apply to a subset of my projects. That's the bringing things together in one control surface that Command Center does for you. And then as your developers spin up new projects and the organization continues to grow, then these policies get applied automatically and reduce that danger of inadvertently someone spinning up something in your blind sight, out of sight, and then creating a vulnerability to access either patient data, healthcare data, or some of your machine learning analytics data that might be proprietary. And so first step, providing that central place for coordination, for control. When we think about the premium version of the product, we really are thinking about 4 main native Google security detectors that help you become more secure. On the prevention of threat side, which means the finding of vulnerabilities, the finding of weaknesses in your system, it's focused around 2 things. Security health analytics, which provide both inventory and monitoring of the resources that you've deployed on cloud, allowing you to find misconfigurations, which analysts have said account for nearly 70% of all breaches are due to some sort of misconfiguration, misunderstanding of how you actually configured your cloud. We also, as a part of the security health analytics, provide continuous compliance checks, and some of those listed here: PCI, CIS, and then SOC, as well as NIST. On the web security scanner side, what we're doing is we have a native detector which will actively scan your publicly facing web applications and find things from the OWASP top 10. And then as we have now identified vulnerabilities around the surface of what you've deployed, whether it's the resource or the applications, we then also include the ability for you to actually detect active threats, which means bad guys in your system doing bad things. And so event threat detection is a service that monitors all in real time, all the logs, your network logs, your IAM logs, to actually detect behaviors, leveraging the threat intelligence that Google uses to apply and find things like malware, essentially anonymous IAM grants, or potentially brute force SSH attacks, or the exfil of data to known C2 sites. And then, as I'm sure you guys, as you look at the hackathon and as things are developing, containers and building really in a container-centric model are further becoming the norm for folks who want to move fast and also have that immutable kind of set of resources. So we have, as a part of the Security Command Center Premium, the container threat detection product, which gives you an embedded agent in all of your containers to allow you to detect key built-in threats that we'll talk about a little bit later. So first up, when we think about, again, the main source of where folks get owned as they spin up things in cloud in general is around vulnerabilities and misconfigurations. So setting things up wrong, the classic one is leaving certain buckets public or leaving certain firewalls open so that the aggressors have that ability to get access into your system. And so Security Health Analytics is a product native to Google Cloud that we have developed to address this, right? It gives you continuous security monitoring in near real time. It monitors your storage so that it finds and identifies publicly exposed buckets. It also identifies where you're not using bucket-only policy, when you're using legacy ACLs, so that really the configuration of where your data is stored, you get a very good look at what the security posture of that is. Similarly, on the networking side, we look at how you've configured your firewall rules, your VPC structures, how you set up your networking. and again, identify the most common places where things have been misconfigured, whether it's overly permissive firewalls that allow all addresses to access across all ports, whether it's the use of the default or legacy networks that don't have enough logging built in, or that you're not using private access to Google APIs so that many of your calls to Google services are actually over the public internet. So those are all things that we check for on an automatic basis. And if you've done anything in security, you know that logs are king, meaning that in order to actually figure out what's happening, whether it's in a live situation where you're looking to see how much lateral movement and whether you can catch the bad guys in process, whether it's retrospectively when you're doing investigations, you need the logs to actually be able to figure out what's going on. And so one of the key misconfigurations folks have is they actually don't have logging turned on in many cases. So our ability to kind of scan across your organization to see for particular resources if the correct amount of logging is enabled is built into security health analytics. If we think about your compute, whether it's in VMs or GKE, which is managed Kubernetes, the ability to really have the best practices in place out of the box. So again, public access to VMs, disabling IP forwarding, or if you're using our GKE clusters, using private networks, basically private clusters, those features which are native to our platform, if you're not taking advantage of them, then you're in a weaker security situation. And then last is, as we talked about, and as Ro talked about, compliance is a good framework where many folks, in order to transact business, require that you meet certain compliance standards. And that gives you a view of all the different portions of security and how you might configure against those. So we have a number of built-in compliance checks around PCI, ISO, NIST, and others, and we're going to increasingly grow those so that automatically across what you're running, we give you a sense of how things are meeting relative to compliance standards. Here's an example, and I'll actually show a live version a little bit later in the talk around really the compliance dashboard we have. So we tell you against a particular standard, how many of your resources and how many checks have passed, how many have failed, and then as you'll see in the demo, you're able to dive in and explore each of those in detail. And this gives you, as you'll see, just reports based on each of the regimens, the compliance regimens we support. If you think now that once your infrastructure is in a better secured state, the key now is the applications that you build on top of those, especially those that you, again, expose to the public internet, because that's where, as Rohit talked about, if you have a very hard shell model of how security works, then folks are going to be trying to come in from the outside. So the first line of defense is to make sure that the things that are public exposed don't have vulnerabilities. So when you publicly expose your web applications, we have a scanner that automatically crawls the various public and, if you give us authentication, authenticated parts of that web application to find basically automatically key vulnerabilities that might exist in the application. And one of the cool aspects of the Security Command Center Premium product is we automatically configure those scans for you across all the public applications that you have surfaced, so that out of the box you get a default sense and a baseline of scanning against those. You can then further go in on a per application basis and further tune those particular scans. But out of the box, we have a set of scans we run across all the publicly facing web applications that you have, and we run against the number of the OS top 10 items. That is all then brought again back together into the Security Command Center dashboard, so you get to see how those vulnerabilities interact with the vulnerabilities that you might have on your resources. Here's again a screenshot. We'll show it in the live demo of what this looks like when you look at your security health analytics dashboard, the vulnerabilities that are available, and then what type of standards that they have been found against. If we switch over now to, the first part was about automatically helping you find weaknesses in your own system and setup and configurations. The second part of this is finding folks who are trying to exploit those weaknesses live in real time. So event threat detection, which we launched to GA back in January, has that ability to look at all the different events in your log streams, whether it's cloud audit logs, syslog on VMs, network logs, DNS logs, the different type of traffic instances that are occurring, and also IAM logs. And that allows us first to then take those into our system, normalize them, align them on time and resources, apply Google Threat Intelligence and our own detection logic, and then churn out a set of detections about what we found that are potentially malicious bad activity, surface those in the Security Command Center. So again, you have those in one place so you can see what threats are being identified relative to the vulnerabilities you have, relative to the resources that you have. An example of some of the things that we've launched as a part built into event threat detection, the ability to detect malware, the ability to detect coin mining in your system, data exfiltration, incorrect IAM assignments, the ability that somebody has compromised your machines and is trying to use it as a DOS cannon against other resources, people trying to brute force SSH, essentially behavioral analysis around either IAM behavior or behavioral analysis around the use of service accounts, and then access to particular known bad IP sites and Tor nodes. And these are all come built in to Security Command Center Premium as a part of our event threat detection. And similarly, as I talked about in the beginning, it's useful to understand as the center of massive development is going, moves to containers. We believe it's important and differential at Google Cloud to provide you some built-in threat detection for those containers. So what we've done is combine two things. First, a Linux security module, which is baked into the container optimized OS that we have, which provides that ability to understand what's happening at the container level. And then separately, we also have an agent built in at the machine level, which allows you to look at and connect what binaries actually were compromised from which containers on which machines at a particular point in time. And that's unique in industry because typically folks are either tied to the container or tied to the physical, but not connecting the two of those together. And so some of the things that we're detecting out of the box are the execution of additional binaries. So when folks have now linked things in and are running malicious code on your containers, when folks link libraries in, similarly the ability to inject malicious code, or things that are opening up shells back to the public internet, which is typically an example of folks trying to exfil information or phone home. Those are key detections that are built in fundamentally into container threat detection as a part of the Command Center Premium product. So Command Center Premium is a paid product, which we provide as an all-you-can-eat annual subscription. So as you talk to your organization, you think about security for your production workloads. One thing that we did when we devised the product is want to make sure that you didn't sacrifice scale and cost for the security that you have. Meaning that we want you to grow as big as you can without having to incrementally pay more for security. And so we have a unique pricing model for the Command Center Premium for your organizations, which is an all-you-can-eat. You buy a subscription for Command Center Premium, and that service is available to you irrespective of how large you grow. And so that's unique. So it's not a usage-based model. It's actually a fixed-price subscription model. So what I want to do now is actually switch over to the demo. So I'm going to change a little bit how we do the screen share. And then go from there. Hold on. Okay, so hopefully you guys can see my screen. So now this is a live version of the Security Command Center for a particular organization I've set up. And what you see is you're greeted immediately, and we're looking out for the last 30 days, as how the vulnerabilities by severity have changed over time, when certain threats have been identified throughout the system. Just to kind of ease the mind, this is a demo system, so it's meant to have activity against it. Your actual live system shouldn't have this much activity. We'll also provide like what were the highest and most severe items we found from a vulnerability standpoint. You can also look at that from an asset standpoint, which assets have had the most, and then from a project standpoint, which projects have had the most issues, either severe, medium, or low. From a severity standpoint. So that's the thing you're greeted with. You're able to now go explore critical, medium, high findings across the different pieces. Fortunately, there are no critical ones. When you look at now to threats, which are about malicious activity that's actually in your system, we see there's one malware, bad IP thing detected over the last 7 days. and then we understand which resources those have been applied to. From a vulnerability standpoint, we get a summary of all the vulnerabilities that have been detected in your system, again, over the last 30 days, which benchmarks those are a part of, and so we see a lot of cross-site scripting risk on a particular set of applications. You can sort this on either the status, which is everything with a triangle is something that's actually live in the system. Things that are green check marks are checks that we do that have found nothing. You can sort by severity, so we can look at low severity, high severity. You can sort by the number. You can sort by the categories alphabetically. You can sort by when they were last scanned. So the more recent. You can also sort by whether they exist. And then you can also filter this down. So this is across the whole organization, but I might want to look at just a particular sub-project, and then you get that same view. So for someone, again, as we talked about, who's interested in protecting the whole estate that you're running your healthcare apps on, protecting the various types of data, this gives you that view and the ability to drill in. As we talked about from a compliance standpoint, that ability to now look at an overview of against all the different things, either at a project level, or if I kill this, look at this at the overview level, how many different warnings, how many things have passed, and then by specific security regimen. So which items and which standard, how each things have done. And now the nice thing is that not just as a high-level dashboard, but the ability to actually really drill in detail, the ability to either look at your assets, and so you can look at the individually. So for example, if you have a BigQuery data set, and then you wanted to see if there is a particular item in that BigQuery data set, you can see what the data set is. There are no findings against it, the underlying resource data, underlying timeline for the asset. If you were to look at a bucket, we can look at a specific bucket and then see for that bucket, there are 4 findings against that bucket. So logging was disabled, the bucket policy was enabled, there's no retention policy set. So that level of granularity for you to dig into details and investigate more. And then we similarly do that for the finding. So what I've pre-filtered here is finding what is a bucket that has a public access enabled. So now this is a publicly accessible bucket. It's a high severity finding. We give you the guidance of how you might go fix this, and you can actually click into here and get to the specific bucket and immediately make that change. This also allows you to look at all the different input sources of data, so all the asset data, all the various types of detectors we've enabled, including the data loss prevention API, which we enabled and we recommend you guys use to do data discovery, finding things, and either PII or FHIR data within your data sets. That's directly integrated into here, so you can see those against the particular either BigQuery or GCS buckets. So overall, this gives you the ability to think about what's happening in one place across your organization. Also, we integrate with a number of partners, so if you or your organization are using a range of other security providers, you can also have their data implemented, executed in one place. So, if we go back to looking at things, the key item ultimately is that we can provide you with Security Command Center the ability to incrementally look at what's going on your premise. Hold on a second, let me just exit this. Exit that and go back to stopping sharing. So yeah, so we provide you the ability to look across your whole estate, have the ability to actually see what's going on in security posture, and proactively find problems before they occur, as well as detect live issues of malicious activity on your system. So with that, I will hand it back over to the moderators. There is both a link to the Q&A session I'm holding after for a next hour, and then also I'll be monitoring the Discord channel. So thank you, guys.
All right, Andy, that was super comprehensive. And I think It's, again, super impressive. I think for, a lot of the smaller, what resonated with me, and is a really simple thing to do, is that logging, feature or function that you talk about is super, super important. And I think you're right. A lot of people forget to do that, take that simple step. And then to have access to all those other dashboards, to get a deeper understanding of what's going on is fantastic. So thanks again for your time today, and agreeing to stick around after for some questions and answers. And we're going to continue to have office hours using Q status, and also just go to the Discord. You can go to the announcement channels, the info channel, the Cardinal Kit channel, and get some more information there as well. So that's it for the live sessions today. Super excited to see what people are going to build. And I think Amir is going to take over from here. And he'll post some information as the reel is going as well, if you need more information for 5 or 10 minutes. But thanks, everyone. And have a great day and good luck. And definitely ask questions if you have needs. You can take it away, Amar.